2. Why is it 2? Why is it 2? Now it is 1. It is 1. I'm calling multiply with power of 4. If ms is 1. So this is going to call multiply with power of 4. This is going wrong, I guess. Yeah, change it to 2. Yeah, that's nonsense. Let's try it again. Wrong, yes. Continue, next step. Patterns. So single vector with a single bit, that is 1. Repeated once. aka 0. May not be empty. Minimum power. Oh, wait. Minimum power is 2. Oh, yeah. That is correct. So that is correct, actually. It is correct, yeah. So multiply by 2. Yeah, this is correct. Hi, Bear Hook. Okay, this works. I have an interesting class here, which is a vector of vectors, but it's just a binary value. But each pattern is possibly a repeated pattern. So say if I have 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1. If I want to store that, I can store it as 0, 0, 1 repeated, 1, 1, 1, and then 0, 1 repeated. Yeah, you too. Merry Christmas. It's still Christmas. Nothing gets repeated just a single time. It's always repeated any number of times. So I don't have to specify how often it is repeated, just that it can be repeated. So in this case we have a pattern. We have two patterns, and the first pattern is a 2, but it has a number of bits set to 1. Oh, I forgot to update the number of bits. Wait a minute. That doesn't make any sense. Yeah, because the type is a ones. If I add the bit to a non-repeating thing, then the number of bits can grow, I guess. Or not. Not really. Actually, it should overflow. See that there is no repeating pattern after it. Insert a non-repeating pattern and then catenate the two non-repeating patterns into one. Holy moly, loads of code, I don't like it. But yeah, it overflowed anyway. Hi, Leonardo. Welcome back. LGL. Yeah, I'll just do I don't know. Difficult. Let's just try this. Yeah, no. Looks slightly better, I guess. Let's print everything on one line anyway, because now it's not going to be that much, at least at first. Yeah. Or maybe it depends on, you know, what is this? Print on of... this one, I think. Okay, now this should be 0, 1, and then it's okay, because the angle brackets means repeat once or more. So if this was 0, 1, then it is at least 1, 0, 1. So then we have 5. 5, and then another 0, 1 after it. You get 21, and so on. And we have all of them. So why is it not 0, 1? So now it is 2 bits. That is 1, 0. There's a 0, 1 here instead of a 1, 0. What if it's happening? Oh, that's because I subtract 1, yeah. Very correct. So now it is a 2, so 1, 0 followed by 2 zeros. 2 zeros. Once or more. And now I'm going to subtract 1 of that. And apparently that is not working. Well, pos unequal patterns end. Well, it isn't. And pos subtract 1, blah, 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 blah. I hate this. Debugging is still possible. Now I'm back. Really? Step into this immediately. This one is different. I want to step into subtract 1 of what our pos is pointing to. That must be pattern, right? Break pattern, subtract 1. Till now we are there. And for some reason this is 2. So not getting it. No, there's nothing for bear. Bear, you missed something. Oh no, you didn't. Sorry, I'm blind. Never mind, never mind. I don't get this. I don't get this. It's really equal to 2. Hmm. I've not gotten my. I do not have gotten my patterns right. They are. They should be inversed. Reversed, I mean. Yeah, totally. I don't know. Mm-hmm. Okay, still wrong. This should have been 1, 1. And the reason it should have been 1, 1 is because I think it should have been 4 and then subtract 1. But it was 2. Why was it 2? And that is after... Case 1 is equal to 1. Case 1 is equal to 1 and then multiply with the power of 4 with a minimum power of 2. That's like 16 even. Yeah, that's right. It is right. So I'm doing multiply by 2, but that's every power, so it is a power of 4. So I really have to do multiply by 4. Yeah, I can do it. No, just 1, of course. Just 1. Well, this looks too ugly. I'm gonna write one especially for 4. Might as well do that in line here. It's the only place where I need it. But if this overflows, that is nonsense. That is nonsense. I'm going to do just times 4. That's perfectly okay. Perfectly okay. Pattern multiply by 4. minus. There we are, but still not good. Or is it? Actually, it is good, I think. Yeah, this is like good. It's good. Is it good? I think it is good. I don't have to print a 0 though. I don't have to print at 0. So the print on of K class, I think. Print pattern. Pattern. No, just first actually. What? Ah, it's not signed. Yeah, it's not signed. This way it's not signed now. Hell. Yeah, how to do this? Let's make this a signed thing. Let's make this signed as well. What is M bits? Just cast this one instead. Yeah, hey, Post Bunny, I'm going back. 1, 1, and then divide by 3, and then we have the right answer here, if I divide this by 3. Still interesting to know why K2 is empty, though. Like, how is that possible? Oh, some guy. I think I'm just going to implement dividing by 3 per pattern until that doesn't work anymore. I'm writing a program to play with the Collatz conjecture. So what I want to do, divide by 3, yeah, implement. Divide by 3. Oh, that's why it's empty, because this returns 0. Man, this is difficult. Very difficult. How do I implement modulo 3? Extraordinary difficult. So I have a pattern like yeah, patterns. I cannot calculate a modulo 3 unless the patterns have modulo 0, I think, because I don't know how often it repeats. That's correct, isn't it? If you have a bit pattern, like let's say a bit pattern, and you have I don't know, some bit pattern, and that bit pattern repeats 0 or more times, so by putting square brackets around it, I'm saying that this bit pattern just repeats and repeats and repeats. And what is the modulo 3 of that? Well, if the modulo 3 of this internal thing, I mean, if you don't repeat it at all, the modulo 3 is 0, because, well, no repeats means it's 0, so, and if you repeat it once, then the modulo is equal to the modulo of the thing inside of it. I suppose that is 1. And then if I repeat it once, I think that for one thing I should add an assert somewhere, that the size of the repeat must be even. So here I have, let's make it a little bit simpler. So I have 2, which is even, bits. And then if we repeat it once, the modulo is 1, and if we repeat it 2, then the modulo is 2. 5 modulo 3 is 2. And then I repeat it even once more, then the modulo becomes 0. Therefore, if I do not know how often it repeats, I cannot calculate the modulo. Unless the modulo of the internal thing is 0. So, if I have repeating patterns, and then some fixed pattern, and then again a repeating pattern, where all the repeating patterns are equal to have a size of 2, then the modulo of the modulo 3 of the whole thing is equal to the modulo of this fixed thing. Now this one, 1, 2, 3, 1, 2, 3, so it must be even. However, if I have a modulo here, a fixed thing here, I mean, then the modulo of this one gets influenced by the fact that this size here is odd. So this modulo is inverted really, because of this size is odd. So the modulo of the total thing is going to be, I should run from 0 to, so I'm just running from pattern 0. Pattern is less than pattern size plus p. And I have an int m, start at 0, return m, that's the modulo. Let's call it mod 3. Then if the current pattern type is unequal once, it's more like an assert. It must equal once, or the modulo must be 0. Try to compile this first. Oh, it compiled. Okay. Yes, so if it is once is not a repeating pattern. So if it is once, then it's okay. If it is not once, then it's a repeating pattern, in which case the modulo 3 of the repeating pattern must be 0. Otherwise we don't know the modulo of the whole. Cannot know it. And if the type is once, then the modulo might be non-zero. So then I update the modulo with, let's just add it. For now, I mean it's 0. The first one, I just get the modulo 3 of that pattern. And now suppose that the length of this pattern equals is an even length. And the next one is also modulo 1. Then I just have to add them all up. Yeah. And then I have a len. It also starts at 0. And the len must be added the number of bits of that pattern. That also compiles, right? Now if len is odd, then I must do then I must invert 1 and 2. Let's do this one first. Let's first calculate that bloody modulo. So in that pattern modulo is yeah, let's do that inside here, not for the assert. Pattern modulo. So I can just add it and then let's manipulate the modulo. If it is an odd length, well, since I do the mod percentage 3 anyway, I don't have to test that. This is an inversion. 3 minus 0 is 3. 3 minus 2 is 1, and 3 minus 1 is 2. It's all good. And we add that to mod 3. Now we do the modulo 3 at the end. Cannot go wrong. I think I just implemented the modulo. And that would give us output on K2, and maybe even more. So let's check that, if it compiled. Dang, no output on K2. Interesting. And I do not really get it, so let's try to understand that first. Break main, run, next, K1. So at the moment I make K2. We're going to run over stupid P. So maybe this is empty. It is empty. Oh, why is it empty? Okay, and that also empty. Yeah, that's not right. That's not right. So it thinks that the modulo of this thing is 0. Oh, it is. It is 0. I have to divide it by 3 first, otherwise it just stays obviously 0. Yeah, stupid. Okay, and then we'll have to implement divide by 3 first. Maybe this works, who knows. I'm first going to add an assert that the number of bits for a repeating pattern is always even. There's something with m bits. Skip m bits is here. And even this would be an assert then, I guess. So m type must be non-repeating, or the number of bits percentage 2 must be equal 0. In this case the type is ones, so incrementing m bits is okay. And here we add 2, so nothing changes there. And it just returns m bits, and here we do nothing with m bits. Just shift m bits. Create the same thing. I guess that's it. Yeah, okay, I was going to implement divide by 3. The last function. Yeah, well, I think it's more complex than that. They're much more complex, probably. Oh, I already know that. But to make a little bit of progress, I'm just going to assume that all the patterns are divisible by 3. And then do that. That is a pattern P and divide by 3. That's my 3 there. Let me think. Doesn't change. I can just run that directly on the patterns. Except that no, I don't have that. I don't have non-const access. I can make non-const access. It's more complex than that. But I do it anyway. Pattern divided by 3. Pattern. Make a non-const accessor for it. So then we call divide by 3 on number, which will automatically assert when it is not 0, modulo 3. That's a bit quick. I'm doing the modulo 3 on class. Let me just print this. It is a DQ of 2 elements. The first pattern being a digit equal to 1, which repeats, and the second pattern being a single digit. 3 bits, but okay, it's a ones pattern 003. Yep, that is not the modulo, that is not 0. It's also not repeating. The modulo of this one should be, I don't get it. P 0. And patterns, but should have done that, I guess. Zeros, all zeros. Type equals 1, so this should never assert. Type equals 1, I mean type is 1. What? Oh Maria, nobody. It's just open source, do it all for free. Did we assert or did we not assert? We did assert, right? Did assert, right? Assert that equals 1 or whatever. Well, it is 1. So why did we assert? Come on, why? What the hell, man? I'm not looking. Oh, and now we're going. What? No, it's not true. Why am I going into modulo 3? Equals modulo 3. Oh, it's CK class modulo 3. Never mind. Never mind. No, I don't get it. How can we assert on this? It is both equal once and equal 0. So both are true. And still we assert. Someone help me, because I really don't get this. Can anyone enlighten me? Okay, while the chat is thinking about this, I'm going to get me a new cup of hot chocolate milk. Yeah, okay, Nick, I'm back. I was making hot chocolate. Well, the problem is that this line asserts. See? Assertion m patterns p type equals 1s or m patterns p pattern modulo 3 equals 0 fails. That means that this is false. That means that this is false and this is false. But if I print it, it's true. And even this is true. Both are true. So it does not make any sense whatsoever. So now I am in this frame, about to execute this assert. And I let the debugger evaluate this expression, and it is true. And I do next, and we crash. Explain that to me. Oh, are you listening on? Are you listening to the stream, Post Bunny? Oh, you can't type. You're driving, so never mind. I just wanted to know if your kid can hear me as well, or if you're wearing headphones. I guess, yes, she can hear me. Okay. Hello, daughter of, well, I don't know your name. Okay, cool. How are the Christmas lights? Do you like the Christmas lights? I think you have a cool mom. It's nice to be driving around with your mother, right? Looking at the Christmas lights. I hope she's not going to hate me, Post Bunny, for taking up all your time. All the time. Maybe you should turn the car radio off and have some good quality time. Okay, I still do really not get why this is crashing. So it makes no sense whatsoever. Not even one little bit. Yes, Omnic. Or it even short circuits, Boolean short circuit. If the first one is true, then the whole thing is true. So the second thing shouldn't even be evaluated. So since this is true, it's true. Stop. But I'm just going to split it up in Booleans. I mean, I don't understand it, but this is the trick. Split it up in as many things as you can. Now this would not even have been evaluated normally, but well, had it anyway. Same thing, right? I just assign those Boolean expressions to test, and then I do assert test 1 or test 2. Same thing. Now they are suddenly both false. P is still 0. And patterns type. is still ones. So we crash here. The debugger says it is equal to ones, but testing it gives me false. Okay, let's print ones. Let's print ones as a decimal. I think that's D, or what is it? 0. Print type as a decimal value 0. It's totally equal. Why is this false? Oh my god, this makes no sense whatsoever. Since when is 0 not equal to 0? Twilight Zone music. Where is the Twilight Zone music when you need it? That's probably copyrighted, so unfortunately we cannot play it. Thank you, YouTube. No Twilight Zone jingle. Makes no sense. Makes no sense. It makes no sense. Rest time, damn it, fuck off. It makes no sense. I'm running a dot out. Compile it. It succeeds. It produced a dot out. I run a dot out without debugger. It asserts. It makes no sense. Seriously. That makes no sense whatsoever. I'm going to print test1 standard cout per test1 equals test1. I'm also going to print a value of pattern's type. And even the value of ones. Type returns a p type. I don't have another type. And p type is an enum defined with the word ones in it. Ones is equal to 0 because it's the first one of this enum. I'll even put that around it, just in case that matters for some reason. Nah, it should not matter. I'm also going to cast this to an int to be sure that we get to see everything. Hell, make it a long. Yeah, suddenly we get types 2. Okay, well, 2 is unequal 0. I agree with that, about that. Was also already the case here. Since when did I miss that? But printing stuff actually works, apparently. Printing shows the same as that cert is failing. Type is 2. Okay, now I'm going to do it in the debugger. Yeah, type is 2. So I cast to a long. It is once, but if you cast it to a long, it is something else, or? No, it's 0, but it prints 2. So annoying. Seems that the debugger is broken. The debugger is not printing the right values. That is the problem. No, I guess also the modulo is not correct then, but why is the type 2? P is 0, is actually the type should be 2, yeah. But the modulo 3 should be 0, so I should print that as 2, because this should still be true. We need to print more, because yes, it happens that it is... Okay, the modulo 3 returns 1, so that's also not equal to 0. Big Gus 22. Who exactly are you talking about? I mean, you can't be talking about me with this guy. If you mean me with this guy, then what are you talking about? Did you read this sentence and this one? Maybe we have a Stack Overflow? Nope. No digits at all. Yeah, no, it seems that debug is broken. Debug is broken. Cannot do operator square brackets on a DQ. But I've printed like this. It prints the actual values. So with P is 0, I mean, we get the first element of the DQ, which is that one, right? Which then is has a m digits of size 1 containing a single 1. So the modulo 3 of that is 1. And the type is once or more. So yes, now I understand why the assert fails. Gurkum, hello. Oh, what is this? Annoying. It is a repeat of 0, 1. How did we even get that then? I should not have a repeat of 0, 1. I was using it all the time, and the problem in the end turns out that GDB prints the wrong values. The debugger is broken. And apart from that, I have a bug in my program because I really don't get how I get 1 in here. Makes no sense. It looks like nothing works anymore. Okay, this thing set print static all. This thing has a DQ with one element being vector size 1, just 1 bit. It's equal 1. So this is as 1 as you get them. It's just 1. It's equal 1. Why is it equal 1? Because it is set it to 1. Oh, no, it's not true. Okay, it's just 1. So copy that, now it's 1. Then we do multiply with power of 4. And ms is 1. So I multiply with a power of 4 the minimum power of 2. So 16 or 64 or 256, etc. I thought I saw that working, so I'm just doing next and then print it again. Now we have 3 bits, 4, so that is printed in I cannot print it in binary, never mind. So ones, that is 0, 1, 1, 4, and then we get ones or more 2 bits, both being 0. Yes, and that is repeated once or more, sorry. So once or more, I note like this. So the minimum value is 10000, that is 16, and then we add 2 zeros, that is 64, and 2 more, that is 256, and so on. So it's perfectly okay. This worked. Now I'm going to subtract 1. If I subtract 1 from this, then I get 1, 1 repeating, of course, and I have to borrow 1 from that, so it's going to be 0, 1, 1. That should be the result after subtracting 1. I think that worked also. And indeed, it is once 1, 1, 3 bits, so 0, 0, 1, 1, followed by 2 bits, both being 1. Repeated once or more. So it says 0, 1, 1, repeated once or more, 1, 1. And that was correct. That is correct. Okay, and then I subtract 1. And then I do not divide it by 3. But it should be divisible by 3. Okay, I think maybe I'm starting to see the thing. I'm starting to see it. Subtract 1. Okay, yeah. Next. Did I already do that? Subtract 1. No. After subtract 1 we get this. We get this with the ones. And then we do divide by 3, which doesn't do anything. So now it's still... And it isn't. Oh. My divide by 3 worked. Oh, that's right. I did implement it. Really? Really? Yep. So I divided this 3 by 3 becomes 1, and this 3 is divided by 3 is 1. So now it is 0, 0, 1, followed by once or more 0, 1. And then 0, 1, 0, 1, 0, 1. So it's still good. Still good. But I cannot calculate the modulo 3 of that. Finally we're there. Okay. Yeah, I'm getting it. Finally. Okay. Yep. Next. So what I'm used to do is running over M1 as well as over M2. But in this case, that was like pre-sorted as function of the power of 2. Well, I don't have power of 2s anymore, so we cannot do that. Therefore, we have only a single thing, everything in one, I suppose. Yeah, kind of. So I don't have an M1 anymore. I don't have an M1 and an M0 anymore. Let's remove them. container of KC class. I just have, let's call them MK. Elements of KS. Period. Okay, now I'm not having M1 anymore. I should just add it to K, I guess. It doesn't matter anymore where I add it. And then I'm not running over all elements in M1, I'm just running over all elements in MK. KS1, I don't know why it's called 1 anymore, but it's not. And we are not running over this at all anymore. And I guess sorting is no longer needed, or am I mistaken here? Yeah, I don't think sorting is needed here anymore. Might be needed, but I'm not sure. But I might as well sort it, why not? Oops. Okay. Yeah, okay, so I have to do something here depending on the modulo. This code definitely has to be changed. Now, what is this? That's just printing. If I skip that, am I then done? Yep, then we are done. So I have to fix my printing. And I guess I can just print the whole container. So all this code can be removed. Yeah, don't need iterators anymore. This can depend on the size of MK only. And then this is no longer needed. And then we just print an iterator, and that runs over all the elements of MK. Or I can just do K, I guess. MK. And then we just print K. And now to fix this, damn it, my chocolate milk is gone. I drank it all. Oh, what sweet. How cute. I'm really, yeah, I'm really touched. Oh, that's so cool. She's thought I could hear her. Yeah, she was on the radio. And she's good with numbers, I hear. Tiersen, yes, I am. Okay, something very difficult is going on here. I guess I'm at this point, because I don't sort it anymore, I'm not interested to calculate the modulo anymore. I can just push it back. I doubt that. Disprove it is probably, one, not possible because it's true. And secondly, they already tried it. All numbers till 2 to the power 68 have been tried with a computer. And I don't think that running over all numbers 2 to the power 68 is much faster. So if, now, for in the case of K1, I guess all the numbers are no, K0 is 1 times 4 minus 1 is 3, so we can divide that by 3, and therefore it works. But then the next one, we have a problem, because now I have numbers that can no longer be divided by 3. But okay, I'll see what happens if I do this. Just run a dot out. Yep, divide by 3 failed. It still failed, as it were. So let's run it in the debugger and see what exactly it's trying to do now. Do we have bit on divide by 3? I'm just going here. I have ks plus 1 is now Okay. Ones. 3 bits. 1, 0, 0, 1. 0 or more. 2 bits, both 0. That doesn't seem right, does it? Pattern, and then ones, 2 bits, also 2 0, both 0. That's really weird. And it doesn't look right, I would say, but okay. Oh wait, there's even more. Followed by once or more. So the other one was once, 0 or more. Now we get once or more repeated, 2 bits, both 1. So that seems to be the pattern at the moment. So again, digits, 2 bits with the value 1. Oh, that's not correct. The value is 1. We have 2 bits, a value of 1 repeated once or more. So between angle brackets. And then I get the value of 0, 2 bits. And that is fixed. And then we get the value of 1 again with 3 bits. No, I'm skipping something. I should have printed. Yeah, that's it, I think, yeah. Now, how did I get that? I'm not convinced it is even correct. Well, okay, it's not divisible by 3, so... Computes, yeah. I agree. It's a computer program doesn't prove anything, but it definitely helps to the point that you're certain. And then, then you can write a formal proof. Once you're certain that, you know, okay, this is how it works, and then you can try to really write it in pure math, which would not have been possible without a program. I think I'm going to verify if this is this value is even correct, because I have no idea what's going on there. Doesn't seem to make sense to me, but okay. Yeah, does not make sense, I think, to me. But well, MS is 2. So if I list current thing, frame is now 611. I want to have my breakpoint on, I guess. Let me print this whole function. What the hell? Okay, I'm gonna break in 604. It's a constructor. nonsense actually, but okay. Run breakpoint 1, 606, okay, to continue, and then we have printed K1, and I think that now it goes wrong, right? Yeah. So run again, yes, continue. So then I run over all the values, and then KS equals well, it would be nice to print it, and I don't have to read this. Let's do that first. I'm just going to add some debug output here. Okay, so what we did here, we take 1, we multiply that with a power of 4, with a minimum power of 2. So 1, 2, this is repeated at least once. Then we subtract 1, and then it's 1 with all zeros, so that turns into all ones. Then we divide by 3, then you get this. And that's the solution for K1. So K1 is indeed equal to this. Now we're going to calculate K2. So do next. And then we start with this. Now we're going to multiply it with a power of 4 with a minimum of 1. Well, that seems correct. I mean, we had this, and then multiplying with the power of 4 means that you add two zeros, and the minimum power is 1, so you have to add at least 2 zeros or more, so it's repeated once or more. Completely correct. Then we subtract 1, and then things go wrong, I see. Subtract 1, and now we get this. Is that correct? Oh, it's actually correct. Very good. Totally correct, yeah. So subtracting 1, all these zeros turn into 1, and we have to borrow 1. But we can only borrow 1 from one of the repeats. So the last 0, 1 turns into 0, 0. And then the rest of the repeats remain. But this repeated once or more. And now we took 1 out, so now it repeats 0 or more. It's totally correct. Totally correct. And now I try to divide it by 3, and that's not possible. And it is not possible. It's just not divisible by 3, this. So now we just kick out all the repeats at all. Then you just get 1, 0, 0. That's 4. Modulo 3 is 1. So this is not a solution. I should just skip it and go to the next one. But there is no next one. Now the trick is that if I try to divide something by 3 that is not divisible by 3, meaning the modulo is not 0, then I just have to triple the size. So this thing must be changed into 0, 1, 0, 1, simply because this the modulo 3 of 1 is not 0. Therefore, that pattern is tripled. And now I can divide it by 3. That is, I'm not sure if I can, because there's a 1 here. That still doesn't seem to be divisible by 3, or am I completely crazy now? I don't think it is divisible by 3, no. What is the solution here then? I think the solution is to take out more 0, 1s. It must repeat 3 times, otherwise the modulo of the pattern is not 0. But the modulo of this fixed one is also not correct, so we have to repeat more, just borrowing from this repeat. And if I repeat it once and again, now we can divide it by 3. Finally. So then we get, this is 21, right? So now I get 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0, 1. Which is, for example, well, 0b, 1, 1, 1, if it don't repeat at all, 0, 0, and this must be at least repeated once. So this is the smallest value, 113. Yeah, I don't think so. The smallest value is smaller. Yeah, we must get 5 as the smallest value. What went wrong here? Is it the solution at all? Nope, it's not even a solution. Purple skull, yeah, hello. Dang man, I wish it had worked. What is wrong here? Jesus, let me do it manually. This is what we should get. No, wait. We have, this is what we have, but I formulated differently. And I formulated it as, no, I have to call, sorry, I have to look at K3, which I don't have. let's just print okay, just print K3. No, I'm working on K2. This is the next step. So let's just print K2. So if you look at one of the largest ones, then I think these are the two different patterns that we are looking for. So there's a 1 1, and then 1 1 followed by 0 1, 1 1 followed by 2 0 1s, 1 1 followed by 3 0 1s, 1 1 followed by 4 0 1s, and so on. That's definitely a pattern, right? So you have 1 1 followed by any number of 0 1s. And this pattern is new. I'm also seeing stuff that ends on 1 1, as we should. Although it's a bit scary to think of that as 1 1 1 1 1 0 0 0. I want to really have this pattern as 3 zeros and 3 1s. So I think we should see this 1 1 as a 0 0 0 1 1. And then there is a number of times. So every time it ends on 1 1, it should end on 0 0 0 1 1. But then I mean, I should remove all the 0 1s at the end. So you have 1 1 0 1. So if you remove that, we just have the same thing as here. So it's basically this pattern with 0 1s after it. Is not interesting. Okay, because it doesn't really get it, I guess I should add the 0, 1 as well, and then ignore that or whatever. At least we have done 1, 0, 1 extra. Yep. So now we get the one in the middle at least. So yeah, there is 3 zeros and 2 1s. Yeah, 3 zeros and 2 1s. And that is appended with 0, 1, 0, 1, 0, 1 and prepended with 3 zeros and 3 1s. Oh, 0, 1, 3. That is one of the patterns. And then there is another pattern, namely this one, for example, or this one. So that could be ends on 0, ends on 3 1s, of course, and then we get at least two times 0, 0. But yeah, the 0, 1 here repeats at least once in that case, I guess. So now we can go to the small values. I think that this is a pattern like that, anything with 3 zeros in it. So this is the smallest pattern like that. So that is 0, 0 followed by at least 0, 1 repeated, at least once. But then I have, then I have 3 zeros in front of it is a must. Yeah, we don't see the double 0 without 3 leading zeros, 3 leading ones. So it's more like that is repeating at least once. At least once followed by 2 zeros, and then it never ends on 2 zeros, obviously, so also at least once a 0, 1. So we have this one, I think, and now we have this one. So this gives us smallest value 3. Don't even, yeah, there is a 3, of course. It's 5 1s. So the solution. No, there must be 3 zeros here. In front of it. So 3 is the smallest value, and then we get, what is it? Thirteen. 3 and then 13. I think these are the two. So let's go backwards from there. Let's see what we should have gotten. So for K, that was K2, we want to get this. And that means that before the divide by 3, we should have gotten, let's do that like after the cout. So going backwards, I have to multiply this by 3. Well, 1 divided by 3 is, multiplied by 3 is 3. And 7 multiplied by 3 is 21. On this one also 1, 1. 3 times 3 is 9. And this becomes 21. Yep. And then that means that before the subtract 1, we had this plus 1, obviously, which means that this came from 0, 1, 0. And this one came from 3, 1, 0. No, this is different. So before the multiply with the power of 4 with at least 1, that's kind of difficult, isn't it? I mean, this one is easy. This is just simply connect. And here, this is repeated 0 or once. So apparently the power is not at least 1 here. The power of 2. Unless, sorry, it's power of 4. So yeah, I think it is wrong actually. It should have been probably without this 0. And then we added a 0 because otherwise it would not be divisible or something like that. I think it came from this. It must have been, because now it ends on, now it's just a repeat of 0, 1, 0, 1, 0, 1, 0, 1, which is which is indeed K1. However, what we have is 0, 1, 0, 1. That's what we have. I'm trying to prove it because I'm convinced it is correct. Right, I see the problem. The problem is that we have a fixed value that is leading the repeat. That is setting us on the wrong foot, because we can swap it, because this is a repeat of once at least. This is obviously completely equal to a repeat of at least 1, 0, 1 followed by 0, 1. Which is only the case because the fixed value is equal to the repeated value. And going from here to there is easy. That's exactly what I wanted. So you go here, this is just 0, 1, and then you say, hey, but we cannot do the modulo 3 of this. The modulo 3 must be 0 of this thing. And therefore I just repeat the pattern 3 times. So then we get that, bang. And in this case, actually the same thing, except I take out one extra 0, 1. Why? Yeah, because I missed that one. This has a modulo of 2. This has a modulo of 1. Because this has a modulo of 2, I add a 0. And then we get that. That's how it has to go. So I have to go from here to these two. And then from these two to these two. And then from there to there, from there to there. And then we have the next one. But, well, at the very least, I have to begin with this pattern. Put a repeat on that end. Yeah, let me think. All the repeats come from this power of 4. Which obviously must be appended on the right, except in the first time, because the first time this is one higher, and that one must go in front of it, on the other side actually. Yep. That's it. So I have to fix the multiply with the power of 4. Or I can simply do that first and then add a 0, 0, 1. Sorry, add a 0, 0 after it, because it must be higher than that. I think that's way easier. Just make an exception for MS1. So I'm going to get rid of the minimum power. Maybe not yet. But I'm definitely going to get rid of that. It's allowed that the power is larger than 1. That should not be allowed. Or I can start with this and then append it. But still, actually, yeah, that could do. Or prepend it. Wait, what I'm doing here is I'm place front. And that is what we want to do. Yeah. I'm just going to place front. It's kind of not correct, I have the feeling, but why not? So place in front, and then this must be the minimum power. Modulo 2, I guess. No, not modulo 2. Exactly as it is. If it is 0, it must be 0, 1. If it is unequal 0, then it is maybe larger. It's 1 or larger, I don't care. Then we can repeat it once or more. And then if the minimum power was larger than 1, then I can multiply it by additional 4s in order to keep it keep the minimum power there. Let me try this one. Just simply move it in front of it. What was this? Compiling the wrong thing. pattern multiply by 4. It's only done here. No, cannot do that. Don't need it anymore. I just need to insert sorry, actually I have to keep it. In the end I'm not going to need it though, but oh. So the first time I have to do something else. Place front, yeah. So now it's swapped. So now we have this repeated at least once. So we have 1, 0, 1, that is 5. Or we have 0, 1, 0, 1, 0, 1, that's 21, and so on. And now we begin with this. We multiply that by 4, and at least by 4. Then we subtract 1, and I get this. And then the division by 3 fails, because this is not a modulo of 0. But now I can simply expand this, make the size 3 times as big at the moment I encounter it. And then we are at the end, and then I can divide it by 3. Where did I put my pattern? Or did I put it in patterns? I put it in patterns, sorry. Yeah, this. No, this. Okay, so this was the first step. Yep, so in this case I begin with this, and then I must actually immediately expand this one to this, and then do the multiply power with 4, etc. But then how do I get this one? think it has to do with the total modulo. It's not just expanded with 3, but also get all the repeats, I think. So I have to consider multiple things. So I encounter, damn it, pressing caps lock. I encounter this, and I'm going to say, okay, this repeat is not modulo, it's not 0, modulo 3. Therefore I have to expand it, and I'm going to expand it like this. I mean, just forget about the last one. I'm just looking at, really getting crazy here. Forget about that one for now. So we're going to look at 0101. It has to be expanded like that. Now it can gobble up this one, right? That is really, really annoying. Yeah, it could gobble up that one. It's a special case. Normally I would say I have to look at these. So repeated once, repeated twice. Yeah, repeated 0 times, and then repeated once, repeated twice. I'm not gobbling up this. This encapsulates everything. This is repeated, sorry, this is repeated once or more. Oops. So we have to do it like that. I cannot edit that, of course. Let's go to an edit. Okay, we have this, and it must be repeated once or more. So I have 0, 1, 0, 1, or 0, 1, 0, 1, 0, 1, and or 0, 1, 0, 1, 0, 1, 0, 1, and so on. But the repeat must be at least this. So I cannot put 0 repeat of 0 around it unless I add at least 1. And then I need then we have 2, and then we have 3, but that's unequal to this. And this is equal to this. So this pattern expands into this. So we have at least 5. So we should start with this one. It's 5. So just if you ignore this repeated 0 times, you have twice 0, 1. This is at least 3 times 0, 1. This is at least 4 times 0, 1. And if you want to have 5 times 0, 1, then you have this again. Repeat this once and etc. So this is the correct way to expand it. Yep, and then this one drops out because the modulo is 0. Editor's fucked up. This one we keep because it's modulo 1. And this one must be multiplied by 0. Because it has modulo 2. Sorry, it is 2, modulo 3. Keep forgetting, keep mis-saying that. Now, did I do that right? Let's see what I needed. I needed this. So yeah, that's this one and this one. So the 0 comes afterwards. Now going from here to there is annoying, but yeah, I'll have to do that. In fact, I could go in one step to these two, I think, because you just have to calculate the modulo anyway, and then yeah. Donut, am I sexy? Well, are you sexy? That is currently the most important thing here, of course. Well, to me anyway. What do you think? We have it right? I think I should go to bed-ish. Yeah, I think I'm going to bed. The problem is, however, I should continue with the Vulkan engine and not get stuck on the Collatz conjecture for the next 5 years. Which is exactly the danger of that mathematics. But it would be so much fun to have just this done, you know, just one more step. Cry. Cannot be that hard. So I would say I really want to put one more day into it. So it really feels annoying to stop. So I think I'll continue with this tomorrow, and then hopefully we'll get at least these patterns working. Yeah. Okay, so we need something that we input this and it spits out a pair, I think. Spits out a pair where with both being equal to 1 modulo 3. So there's a penta-0 as well. Mark? No, I assume that it is unsolvable, at least by me. Because great mathematicians have thought about it for a very, very long time. They all failed. It's just intriguing. That's the only thing. So I'm not claiming that I even think that I will solve it, but I'm curious. I'm just very curious. What will happen if I do this? Will it show a pattern? It must show a pattern, namely, because I believe that the conjecture is true. So, yeah. Having done this, I can ignore all the patterns. So we know the patterns, but I don't have to print them anymore. And then I can print the smallest number of each ks. So the smallest numbers that give you the next step, one more step, as a pattern. And then I hope that maybe I see a pattern in the pattern, if you understand what I mean. Probably not going to happen. By the way, I did another derivation, yeah. I asked myself, how does a number look like that grows? New topic. So I have an n and I want it to grow. Well, that means that the n is odd, right? That means that if we convert it to 3n plus 1, well, that is n is odd, so 3 times odd number is odd, plus 1 is even, so we can definitely divide it by 2. If then it's still even, then it would not grow. Because if you divide it again by 2, then you divide it by 4. So you multiply it by 3, you divide it by 4, it becomes smaller. So I demand that this number is odd. And I'm not going to repeat the derivation, but it turns out that in order for that to be true, n must be of the form 4k plus 3. You can actually prove that very quickly, if you already know it. So we just multiply by 3, again 12k plus 9. And then you add 1, so it becomes 10, and then we divide by 2, so you get 6k plus 5, which is odd. Yeah, so that's at least this is true. And this is also all of the values. You just fill in any positive number of k, and you get all the values that will result in an odd value after this. But okay, that's just growing once. What must n be so that if you repeat it twice, this is again of that form, so that it grows twice in a row? And lo and behold, it turns out that is 8k plus 7. This grows twice in a row. And to grow 3 times in a row must look like that. And to grow 4 times in a row, it must look like this. Well, you see the pattern. Now we just simply pick k. K is 1. I don't care about k. Then we have a number of 1s equal to power of 2. So this gives us 4 times 1 is 4, plus 3 is 7. So that is a power of 2 minus 1 number of 3's. This gives us 1 times 8 plus 7 is 15. Oh no, I'm wrong. It's just a number of any number of 1s keeps growing. Okay, so two to the power of 30. It's a big number. No, minus 1. This number keeps growing 30 times. But it's already a big number. Maybe it doesn't even fit anymore. I think it maybe it doesn't. Let's make it a little bit smaller. Let's say 28. So this number should grow 28 times. Or am I completely crazy? Let me try that. No, I lost my input program. Shit. Should not have edited that. Yeah, that seems to be correct. It grows 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27 times, and then it started going down again. And it goes down fast once it is random. So every time you get a number that ends on a number of, so you get some random number at some point, yeah. And by coincidence it ends on a few ones. Then it will grow very slowly, 1, 2, 3, 4 or 5 times. And then, yeah, then it doesn't grow anymore. It goes down again. So it's just pure statistically, it is very, very, very clear that every number goes to 1. It is impossible that it keeps growing. But there are an infinite number of numbers. So there is always a chance, unless you really prove it, there is still a chance in my eyes that there is some huge number of, like, say, Googleplex digits that goes in a loop. Although, yeah, I guess then that the chance that that happens is also 0, because then in order to get into a loop it must become, you know, like all those digits must be the same again. So that's the larger the number, the smaller the chance, and the chance that it grows enough to have several chances, say to, no, it's just, chance is just 0. Chance is 0. But that's just statistically. So that's the interesting thing. It is probably true, because statistically it just has to be true. But to actually prove it is impossible, because it's only true statistically. There's always a possibility that one of the infinite numbers does give a loop. And I think that the only way to find that or disprove that it is possible, aka prove the conjecture, is by doing a full analysis. And that's what I'm trying to do. A compact way to write formulas that, you know, just describe it exactly without growing out of bounds. Probably the wrong approach as well. But okay, I don't know, I have fun, that is true. I didn't even grow to the quadratic. The largest number here is this one. Does this thing do square root? Nope. Yeah, this I cannot. I want to do the logarithm of that big number, but I don't think BC can do that. That's a quadratic. That's already a lot larger than this one number. And that's why the chance just keeps going down and down and down and down. Alec, yes. That works. That totally works. No, I already moved much faster, further now. So before I had K1 equals 5, 21, 85, and so on, and then at some point you had to stop. Comma, dot. But this is all of them. Absolutely 100% complete list of K1. Namely 0, 1 repeated once or more, and then 1 extra 0, 1. So this is now perfect. This is perfect, and I'm working on the next one, K2. Once K2 works, I think all of them will work. It's just the last step. So then I can produce a very concise things, except not really concise, because every next step it grows a factor of 2. So this is a single pattern. The next one will have 2 patterns. And then the next one will have 4 patterns, and then the next one will have 8 patterns. So it still grows exponentially, even though I have a complete listing now. But hey, maybe we see a pattern in that as well. And if I can compress it even further, if we see the pattern in it, so I can actually print it up till, I know, a gazillion steps. And then if you see the pattern on that, it's just pattern. If there is a pattern, then I think I'm on the right track here. Definitely. This is the way to describe all the numbers. Now, Mark is going to post the proof. You know I was about to stop the stream, right, Mark? I don't know if you were typing or if it was just... Oh, 42, you're right. Yes, 42. That's definitely the answer. It's the answer to everything. Okay, well, I'm going to sleep. Well, attempt to sleep. I'll see you tomorrow. I think I'll continue. I just want to finish